Okay, so up until now, all the variables which we've dealt with in our human being class are non-static. In other words, each time that we create a new human being, he has his own variables. But if you remember a while ago when we looked at the calculator class, the calculator class had a couple of different things. It had a memory, which, you know, it was not static. It doesn't have the static word before it, which means that every calculator we create has its own memory. But it also had a variable called model, which was static, which meant that all of the calculators created from this class share the same variable, and they all start off being a Casio 444. Okay, now that's what a static variable means. There are also static methods, which we're going to talk about in a minute. The most famous of which, of course, is public static void main. Now, let's just jump straight across to our drawing board here. I'm going to try and do a quick explanation. Okay, so if we think of a, where are we? Turn this off, turn it off. Okay, so we think about this as, it's not a very good circle. Think about this, yeah, there's that. There you go. This is the static part. And every time I create a new class, say this is, calculator A, this is calculator B, this is calculator B here. Both classes have their own variables, but they also share this part in common, which is the static. Now, I'm just going to demonstrate that by loading up our example again. And inside our human being class, I'm going to create a variable which is static. Oops. Oh, didn't mean to do that. Going to make it static. I'm just going to have this one as a public variable for now, so I don't need to do a getter or a setter. Public static, and I'm going to call it counter equals 0. Okay, and I need to give it a type as well. Public static int counter. It's going to start off as 0. Public static int. You have to get these the right way around. Okay, so inside my tester class, just to demonstrate this, I'm going to say, well, after I've created my human being, I'm going to say h dot counter equals 5. Okay, and then when I go inside my human being class, I'm going to say h2 dot counter equals 10. So just to recap there, because I said that wrong, when I create a new human being, I access the counter, the static counter variable, using h, which is the instance variable for that class, that object, and then I create another one which I call h2, and this time I access the static counter variable using h2. Now, both of them have access to the static variable because they're both human beings, and the static variable is here, and it's public. So far so good. When I print out this at the very end, what is counter going to be equal to? I was going to say, what do you think? Is it going to be equal to 5, because that's the first value I set? Or is it going to be equal to 10, because that was the second value I set? And remember, I'm going to print out h2's counter. But as you know, they should be the same, because that's a static variable. Okay? In fact, just to prove it, I'm going to say h2 counter equals, and right below that, I'm going to say h1 counter equals, and I'm going to run it. Oops, hang on, I've got errors. First of all, I've got a getter setter error up there. Okay, so I have to pass in a. Okay, I've removed the set age that was in the previous example, so I'll take that out. And in here, what's wrong with you? What does it say? h1 cannot be resolved to a variable. Yeah, okay, because I didn't call it h1, I call it h. No problem. Okay, I'm going to run this code, and you'll see that actually both counters are the same. In fact, it's the same variable they're both pointing to. And what about this? If I decide to, if I want to, I can actually say human being, and instead of saying a reference variable, I can say human being dot counter. So I don't even need to have instantiated any of these, classes at all to be able to access the counter variable. Look, I'm going to run that again, and you'll see that they're all pointing at the same variable. They're all pointing in this very, very same area in the middle, static. And to get access to a static variable of a class, I don't even need to have instantiated that class. I can just access it using the I don't even need to use an object variable. I can just use the base class name for it. So I can say human being dot counter. I can say h dot counter, or I can say h2 dot counter. They all point at exactly the same variable. Okay, so that's a static variable. It's used when we want one variable for every single instance of that class, and we may not even want it to be initialized. And the other thing we're going to look at very, very briefly is a static method. Now, a static method inside a class is one that I don't even need to instantiate the class to use. So inside human being, if I put a static method, let's say public static, I'm going to say hello, and inside that I'm just going to say system out println hello. Public static void, of course. There you go. Now, inside my tester, as well as doing all those other things, I can just go human being dot hello. I can also say h1 dot h dot hello, and I can say h2 dot hello. Now, the advantage of this is that because I don't even have to instantiate a class to use a static method, then I can have a whole library of useful functions in there. And in fact, you've come across this already, because if you say string dot, you instantly get all of the static functions from string. You don't even have to. I could alternatively say, s string s equals new string, and that's the string I'm creating. Whoops. And then I can say s dot, and I get all the static functions as well. But as well as the static functions, I get all the, if I do that, I get everything. Whereas if I do that, I only get this static bit here. Okay. Now, so as I was saying, the advantage of that is I could put a whole load of useful functions in here the same way string does. For example, I could say string dot value of, and it'll return me the value of that string, and I don't even need to instantiate a string to do that. Or I can say integer dot parse int, and it will return me an int variable of 1, 2, 3 without me even needing to instantiate the class integer to use that. So I can make like a library of useful functions and put them all in there. Okay.